Okay, welcome back. Here is a lesson on vertical shifts, horizontal shifts, reflections of the x-axis, and different things whenever we are trying to graph equations that include things like squared, cubed, square root, or absolute value. This is coming partly from Algebra 1, Saxon Algebra 1, 3rd edition, lesson 110. Now, you'll need this for things like the CAT test, the SAT test, the GED, and sometimes they will overlay this with graphs. You have x, y, a Cartesian plane, here's your y, here's your x, and you might see a line drawn like that, and they're going to say, what about a formula with a square root in it? So this is just a simple sloped intercept where we have y equals mx plus b. But what if we have one where y equals mx squared plus b? Where will these points share? Where will these two lines, what will be the solution of the two lines? Where will they cross over? So we need to understand a little bit about the way these guys work. And I wrote it here, f of x equals x squared, f of x equals x cubed. I'm going to erase that f of x because often we just use y instead. What if we just go y equals, y equals, y equals, and y equals? Now, it's important to understand what's going on here. There's 4 different types of shapes that will be formed. Anytime you have a x squared, you form a nice parabola. Anytime you have x cubed, you form a nice shape like that. Anytime you have the square root, you form a starting point and a going off up like that. And anytime you have the absolute value, you form a perfect V on the graph. So this is what the graph of a line, including one of these, would look like on a Cartesian plane of any of these. Most often you're going to see this. Now, the simple graph of f of y equals x squared, if we simply graph that on a Cartesian plane, the parabola point, the point of return, the base of the parabola, is going to pass right through the point 0. And I'm gonna draw it on here. Now, we aren't going to worry for the time being where we are out here, what points we're going to cross over, and I can't really tell you which ones they'll be for the time being. And I hope that's a pretty nice parabola. But it's going to cross over smack on the 0. Just plain x squared with no b, with no plus b, no y-intercept. It's going to cross smack over 0. The same is true of this one. This point, turning point right here, will be smack on 0. This one's point of origin will be smack on 0. And this one's point of reflection will be smack on 0 for these kinds of graphs. So anytime you see this in a formula, squared, look for this shape. Cubed, this shape. Square root, this shape. And absolute value, it's going to be this shape. Now, if this would be a negative, if we play with this and we make this a negative x squared, this guy flips around, right like that. This is a negative x cubed. This guy flips around, right like that. This is a negative radical. And let me look for this because I'm a little bit nervous. Okay, yeah. This is a negative square root of a negative x. Am I doing that right? No, not the square root of a negative. The negative of a square root. This is going to turn and go down this way. And we make this guy a negative, absolute value of a negative x, he's going to just invert. So we see we always have the exact opposite of what's going on. This one, it still moves toward the right, but it goes down instead of up. Otherwise they mirror. Now, what about if we have a point of intersection? Suppose, let's take one like this, and let's go y equals x squared minus 3. That minus 3 means that our vertex, our point of return, is going to, instead of being at 0, it's going to be down here at minus 3, right here. So there our parabola is going to come nicely through. And let's trick this up. Let's make it a y equals negative x squared minus 3. Now, our parabola also inverts. So the parabola inverts, comes up, crosses through the negative 3, and heads down that way. But we know that that vertex, that point of return, is going to be on negative 3 on the y-axis. The same is true, as you would assume, for any of these. If we make them minus 3, we add the minus 3 on the tail of them. Minus 2, plus 4. All we do is we begin to move them up or down the y-axis. Positives go up, negatives go down, as we know. Now, there is another complication. How can we move them from right to left? How can we move them back and forth that way? And here is how that works. If we have y equals, let's stick with our negative, x minus, let's go plus 2 this time, and we put the square root sign out there. Now, lots of things happen. Pay attention, it's pretty easy whenever we said negative is down and positive is up. Now, however, positive is left and negative is right. It's the opposite of what would seem to make sense. How would I explain this? I don't know. Don't worry about the explanation. Worry about figuring out where that vertex is going to be. So I can know exactly where the vertex here will be. We're going to be on the 0, but we're going to be on the 0 on the y-axis. So we're going to be on this axis, but now we're going to move on the x-axis. And since we're plus 2, we come 2 back into the negative 2. Since it's inside the parentheses, we're going to do exactly the opposite. And it's going to be a negative reflection right on there. So our parabola is going to look something like this. And our point of return should be exactly on negative 2, because we had positive 2, and it's in the parentheses. The same rule will continue to be true about these other 3 types. Anytime it's inside parentheses, suppose we go negative x cubed. Then we form that other shape, and we would just cross negative. We would have to come down this way and cross through like that. Suppose we have the square root of x plus 3. This is where, instead of going, this would be the same thing as putting it in the parentheses. So the square root of x plus 3, let's just graph this. We know it's going to graph like this, where we're a positive x, so we know the graph is going to move off and toward the right, and we're at plus 3. So let's go to minus 3, let's back up 3, 1, 2, 3 here, and we're going to go off into the right, over that way. Down here, the absolute value of, let's just make it the absolute value of x minus 2 for the fun of it. The absolute value of x minus 2, y equals. The absolute value of x minus 2, we're going to move right 2 on the x-axis, 1, 2, and it's a nice V because we are in the absolute value style, so we come down and V out like that. Now don't grade my where I'm crossing over these points. This actually should go smack corner, okay? And I made it a little too high. I'm not worried about that. I'm worried about where is the point of return, that point of inflection or reflection. Okay, I think that covers the lesson. But what you're going to have to think carefully about these points. Because look, it would be possible to take an equation and change it like this, and we're going to go y equals x plus, let's go, y equals x minus 2 squared plus 3. Now what happens? Well, now we're combining both of the things. This means that the point of reflection, we're going to have a positive parabola, so the parabola is going to be like this, and the point of reflection is going to be 2, inside the parentheses we do the opposite. So let's go 2 to the right, 1, 2, we're here, and 3 up, 1, 2, 3, so here. So our parabola is going to come pass through that point right there. Remember that if it's inside the parentheses, it moves right or left, but it moves the opposite. If it's outside the parentheses, it moves up or down, and it moves exactly as it says, up or down. Also try to remember the squared is this shape, the cubed this shape, square root this shape, and absolute value this shape. Practice. Work with it over and over until you can begin to see it instantly what it's going to be. I hope you have success.